right, happy Tuesday. I hope that you guys are having a good day so far. All right, so you should have this handout for characteristics of quadratic equations. We're going to look at a real life example using some Looney Tunes with a Wile E. Coyote. So Wile E. Coyote is catapulting a boulder off a cliff to hit the Roadrunner. We're going to let T represent the number of seconds that the boulder catapults off the cliff, and H of T denote the height of the boulder in feet above the base of the cliff. So again, this H of T is also known as my Y value, and that's going to be the height of the boulder. So ignoring air resistance, we can use the following formula to express the path of the boulder. So here's the equation that I'm going to use. Negative 16t squared plus 24t plus 160. It is graphed here, which is kind of nice. So already graphed, I can see that it opens down. I do have a negative leading coefficient of A, which is going to be reflected across the x-axis. So the x-axis represents something significant in my situation. So the x values, if I go up, like my x's are now t's, and I'm going to let t represent the number of seconds that the boulder catapults. So this is going to be time for my x values, and then my y-axis is my h of t for my y's, and that's going to be the height of the boulder. So I'm going to put over here for my y-axis the height. So all along the x-axis, all of my height values are 0. So the x-axis represents the ground. Here is the ground where the boulder is going to hit the ground. So the y-axis kind of represents where my height is, my starting value of the boulder. It also represents like when time starts. So it represents my starting value for the height specifically, and my starting value, sorry, I already wrote starting value, my starting time for when the coyote pushes the boulder off the cliff. So what part of the graph is significant and why? If I'm looking at time, I don't want to look at anything to the left of the x-axis. It's not significant because this didn't really happen. Same thing looking at my x-axis, I really don't want anything below the x-axis because this is my boulder going below the ground. So the part of the graph that is insignificant are going to be to the left of the y-axis and below the x-axis. So I can just name them by quadrants. This is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So my insignificant pieces of the graph are quadrants 2, 3, and 4. Why are they insignificant?
Coach Stafford, please call the front office. Coach Stafford.
They are insignificant because they represent negative time and a negative ground height. All right, so number 3, what was the height of the boulder before it was launched? On the y-axis is when time starts. So before my boulder was launched, it was right here. This point represents the starting of the boulder. So the height is the y value, which is 160 feet. I can also see that as my constant value in the equation. Those should always match up. So the height of the boulder before it was launched was 160 feet above the ground because he's on top of a cliff. What special point on the graph is associated with this information? So it's this point where it touches the y-axis, also called the y-intercept. And the coordinate of the y-intercept will be 0, 160. All right, number 4, if Wile E. Coyote simply pushed a boulder off the cliff, how would the graph look different? So he catapulted it, which means that it goes up before it comes back down. So if he simply pushed it off, I'll just draw a rough sketch. It would still start at the 160 feet, but then it would just drop from there. So I can mirror it on the other side, but it's just going to go down. So, like to describe the boulder would not go higher than its starting height of 160 feet.
Attention teachers, if you are parked inside the gated area or behind the gym,
immediately.
The gates will be locked in about 4 minutes, so your car needs to be moved. Also, if you are parked behind the cafeteria, your car needs to be moved. We are barricading that area, so please move your car so that it will not be barricaded in. Thank you.
All right, so number 5, how long will it take before the boulder reaches the bottom of the cliff? Well, the bottom of the cliff is going to be where it touches the ground. So I'm not going to use my negative time, but this x-intercept represents where my boulder hits the bottom of the cliff. So how long will it take? It's going to be this number 4, which represents 4 seconds. What special point is associated with this information? It is the x-intercept, and the coordinate for that is 4, 0. All right, so after how many seconds does the boulder change direction? So he's going to start with the boulder at 160. It's going to go up, and then it's going to start to go down. So changing directions is from the up to the down. So that's going to be this value here. It's kind of hard to tell exactly what that coordinate is. So I'm just going to say less than 1, because at 1 second it is going down. We will calculate that later this week. How high is the boulder when it changes direction? So I'm looking for the height here, so I need this y value. So if each of these little ticker marks goes up by 10, then this is 160, so it's going to go all the way up to 170 feet will be my max at that maximum value. What is the significant point called on the graph? It is called the vertex. My parabola changes direction. It's also called the maximum value from my extrema. All right, how high above the starting point does the boulder begin to change direction? So it starts at 160. It's going to go up to 170, and at 170 it's going to start going down. So the difference between those two is going to be the how high above does it start to change direction. So it's going to be 10 feet. And number 8, if Wile E. Coyote changes his mind, how many seconds does he have to stop the boulder from going over the cliff? Well, he does not. So he is catapulting, right? So he starts here and it's going to go up and go over. Is that right? So it's going to like automatically go over the cliff. So I'm going to say 0 seconds. All right. So I have another assignment for you guys in looking at situations with quadratics. And again, these will be due on Wednesday.